I also, really good news for me, I found my packet and then I don't know where I put it. Well, that's cool. Well, that's a bump start. All right, power and polynomial functions. This first part is going to be, can we name them? We're not going to do much else for them. It's just going to be, can we name these? Where's my mouse? Squeak, squeak. All right. A power function is any function that's k times x to the p, where p can be any real number. Okay? It can be any real number. So could p be a fraction? Yeah. Can p be negative? Yeah. What makes that different than a polynomial? A polynomial has a bunch of power functions added together. That's what that shows. The n has to be a whole number. Okay, you have been dealing with polynomials most of your life in some form. So let's do this one. Determine whether it's a poly or a power or both. So this is 6x squared. Okay, so a power function is x to some power. Is that x to some power? So it is a power function. Now, is that power a whole number? Like a whole positive number? Yeah. So it is also a polynomial. All right. Crazy. All right. Is this the same thing as 4 times x to the 1/2? Right? A square root is a 1/2. So is it an x to a power? Yes. So it is a power function. But is that power a whole number? No. So it's not a polynomial. Okay? Does that make sense? This is one your homework sets. Is it a power function? Is it a polynomial? This is all right. This one. Is it x to a power? Yeesh. So it is a power function. I don't know why I wrote power function. Let's just write power. Does it have power? Yes. Is it a polynomial? No, because that's a decimal. And f to the 2x. Where all these are x to a power, right? But that x is in the power, so is that a power function? No, that's an exponential. It's not power. It's not. And if you're not a power, you can't be a polynomial. Sound good? Okay. Polly was my bird that flew away. Actually, I teach more about that in geometry, and I teach about polygon, the story of my bird flying away. All right, so um, let's do these ones. Are all these powers whole numbers? Yeah, and then constant is x to the 0. It's a whole number. So this is it's a power, and it's a poly. Okay. This one I have a decimal. So yeah, well, it's still a power, but no poly. And the last one, what is my power? Ooh, it's the last one would be a power function, right? Because it said any real number. Agreed? So it's a power. But what did it say for poly? What has to be true about my exponents? It's a whole number. You guys remember whole numbers are 0, 1, 2, 3, 4, so it can't be negative. Power, no poly. We're like halfway done. All right. This is something you've seen before, but we should talk about again, just in case you haven't or you forget it. Given a polynomial, the degree is the highest degree after your a, or your x, and your leading coefficient is the number in front. You guys remember seeing that at some point? It'll be easier just to do examples of this one. What's my degree of this beast? What's my highest power? 4. My degree is 4. My leading coefficient. What's my number in front of the x to the 4th? 3. All right, what's my degree of this one? 5. Yeah. What's my leading coefficient? What number is in front of it? Same as my money in my wallet, $1. Yeah, that's not much. Would you guys agree the degree of this one is 6? Leading coefficient's 9. So right now on that homework, do you think you could do the first two problems? Because the first one says a polynomial or power. The next one is what's the leading coefficient and the degree of it. Don't worry. Some of you are saying, when is this? I want some more difficult problems, and we'll get there. All right, so why do we care about the degree and leading coefficient? Because if we know the degrees and leading coefficient, we know what that graph looks like no matter what. We can just look at it and say, we know how this is going to behave based on the degree and leading coefficient. If my highest degree, or if my degree is even, start of this page, we're going to use it a lot. If it's even, it's always going to look like a parabola. If my polynomial is an even degree, or if my power function is an even degree, like x to the 8th looks like this. X to the 264th looks like that. Okay, they all look the same if they're even. And anyone that's odd power looks the same. So like x to the 6, 7.
Wait, no.
All right. Now, they all look the same. Okay? They always look the same. So what that means is this. Your degree in leading coefficient gives me the end behavior of a function. Okay? So your end behavior is how does it act at the end. For power functions, it's either going to have one of two options. It's either going to go to infinity or to negative infinity. All right? So what we're going to say is as x goes to the right. So think about it as it goes to infinity, that's to the right, to the right, to the right. And you go to negative infinity, that's going to the left. Okay? So as x goes to infinity, you're going to the right. Negative infinity, you go to the left. All right, this is a lot of reading. You have this. It is a good reference guide. I don't like to teach memorization because I don't think it's good for your brain. What I would tell you is this. Instead of like memorizing that, what I would do if I were you, get my mic's on, make sure I hit record.
You did.
All right, good. Make sure I'm in frame for what I'm going to do. All right. So do you all agree? If I'm a positive even function, I look like this, right? If I'm a negative even, what am I going to look like? Flipped, right? If I'm a positive odd, that's me. It's going to look something like that. If I'm a negative odd, it's going to look something like that, right? These two things I need to know. We'll just think, what's x squared look like? A parabola. What's x to the third look like? It kind of looks so, it acts like a linear actually. Why does it act like a linear? Because what's x to the 1 is odd. So technically x to the 1 has the same end behaviors, x to the third, x to the fifth, x to the 157th. They all have the same end behavior. And then I have to remember that negatives flip them. So my limits, as I go to the right of a positive even, what's this doing? It's going up. So that's going to go positive infinity. As I go to the left, it goes up as well, positive infinity. Okay? So I don't think in terms of this. I think in terms of what does the graph look like? Okay? Yikes, that's a lot to memorize. So let's do an example. So just determine the end behavior. So we're going to have two end behaviors. We're going to have, here's how I write, limit as x approaches infinity. So that's saying as I go to the right, what's going to happen? This might be, I don't know how many of you guys have seen limit notation, but don't be afraid. That's just saying as x goes to infinity, what's my function going to do? That's what this says. As I go to the right, what's this going to do? Is that positive or negative? The 3. That's a positive, right? And x to the fourth is even, right? So that's going to act a lot like x squared. So my graph's going to look like this. So as I go to the right, what's my function going to do? Where's it going? Up, right? It goes up to positive infinity. My answers for this are always positive or negative infinity for this section. Okay? Yeah. What's my limit of this going to be as I go to the left? So as I go to the left, this also is still going to go up. It's also positive infinity. Every even function will have the same end behavior on both sides, correct? These both go up, these both go down. Odds and behavior are always opposite of each other. Okay? Any questions on the notation? Not going to make you write this notation. Usually the homework or where will say, hey, what's the limit of fx as x goes to negative infinity, left, positive, right? This one's an positive odd, correct? Positive front, odd function. So I know x to the third looks like this. Okay, so I have my two limits. Why are all my markers green? Let's do a dark green. So I have my limit as x goes to infinity of f of x. So as I go to the right on this, am I going up or down? Going up. If you're going up, that's infinity. What's my, right away now, I know since it's odd, it's going to be opposite. But I have to do it. As I go to the left, what am I doing? Going down. So that's a negative infinity. All right. Actually, you should think them through. So don't overthink them. It looks a lot more complex. This is honestly calculus. That's the start of calculus. That's one of the first things you do in it. Oopsie doodles. All right. I'm going to do some of the other examples with this. You can watch the other one if you want. But what I want you to realize is this. The end behavior of some crazy polynomial acts the exact, like if you have this long line of 10 things, it acts just like whatever this is. So there's actually neat activity we did in college once. I could probably show it to you guys, but if you graph the two functions on top of each other and zoom way out, they look almost the exact same. Or if you go off to infinity, they have the same ending to them. Because this one overtakes everything else. It grows so much faster that it just acts like that. Okay? Everything else doesn't matter in the end. It's kind of like life, right? Sometimes we stress about the little things, but it was the big things that were the important things that really mattered in the end. That's your life lesson for the day. You came here for college algebra and you got a life lesson. All right. Whoa, mamma mia, how am I supposed to know this end behavior without graphing it? What's my highest power? It's the fourth. This stuff will not matter as you go to infinity. The x to the fourth overtakes it. Right? So what kind of function is that? That's a negative even. Do you all agree on that? Negative in front, even function. So it's going to be frowning. So what's my limit as x approaches infinity of this beast? As I go to the right, on this frowny face, it goes down, like my stocks. Okay. Now for an even, I know that matches on both sides. But I could also look at the picture. I should put f of x in here. I'm really bad at that. So it'd be negative infinity both ways, because no matter which way I go, it's going down. Just like if you start your day being negative, you'll probably end your day being negative. More life advice. All right. Oh no. Same thing with this one. Do I care about any of the stuff behind it? No, I just look at that. What's my leading? Oh, it's a fraction though. And that makes it difference. Does it? No, not at all. The fraction makes no difference. It's still going to look like this, okay? So my limit as x goes to infinity is infinity, right? Goes up. Limit as x goes to negative infinity is negative infinity. It goes down. Yar? Any question? That's all five. That's all 5 too. You need to know 3 things. You need to know if it's a power function or polynomial. You need to be able to tell me leading coefficient degree, and you need to tell me what's going to happen to it as you go to the right and to the left. Sound good? Also remember, in the end, the little things don't matter as much as the big things. All right. Oh. What? Don't do it. We can figure this out. Oh, it's opening on this side. All right, this section is going to take a little bit more time. We are going to, so now we know how they end. What's happening in the middle, right? What's happening in the middle of these functions? So we know how they end. All right, we've seen that. Oh, mamma mia. Here's some things about polynomials. They're continuous. Their domain's all real numbers. There's no sharp corners. One y-intercept. They could have up to n x-intercepts, where n is the highest power. So like if I have x to the 5th, that could cross 5 times. That could have 5 x-intercepts. Now they could have less than that, right? They could have 1. In fact, you could have an x squared that has 0, right? But at most, it would have x squared would have 2. That's something neat. They have turning points where they turn their life around. Sorry, I'll stop. That will be more, that's a precursor to something else we're going to do. We talked about end behavior. I actually am going to skip the graph using technology because I've seen y'all use Desmos. You guys can plug that in and look at it, right? I've seen you guys do it. Here's what I care more about. How do I find the x-intercepts of a graph? What do I plug in as 0? Why? Thank you, thank you, thank you, thank you. Have we seen that before? All right, so to find x-intercepts, we're going to set equals 0. Now, we've factored, we've quadratic, and we've solved using square roots for squared. What do we do if they're higher than a square? Like they're higher than degree of 2. What are we going to do? Let's do some examples. I'm going to show you two types. We are going to do a little bit of the fundamental theorem of algebra today. It is, actually. It's not bad. So we're flying. Let's look at example 3. Find the x-intercepts of this function. What do I do with this function to find the x-intercepts? You set it equal to 0, right? Set your function equals 0, you'll get your x-intercepts. All right. It's already factored. What a great day. Got to hear the wearable song. People online don't know what's going on. No one watches these anyways. No, what do I plug into each piece to get 0? Once I have it factored. Do you agree 2 is an answer? 4 is an answer? And -5. There we go. Those are my x. Well, actually, let's be even better than that. Those are my x values, right? So my x-intercepts would be -5, 0, because 0 was my y I solved for the x. That's the way I remember, like, what is that coordinate? I would have the point 2, 0, and the point 4, 0. Those are my 3 x-intercepts. Okay. Any questions on that one, or you feel okay? If this was the only thing on the test, would you guys be content? All right. It's one of them. All right. I'm going to set this equal to 0. Ooh, this one looks tougher, but would you agree I have a -5? Because it's always opposite, right? What do I plug in to get 0? A -1? A 7? Don't forget that x hanging outside. You got to be wary of it. What do I plug into that to get 0? 0. Whenever there's an x on the outside, that point is at 0. So when I think about when I graph this, there would be a point at 0, 0, right? This one's missed a lot. So my points would be, I'm going to list these from smallest to largest because that's usually how it asks for it in the homework, and that's actually grammatically, mathematically correct. These are my 4 zeros, or not 4 zeros, 4 intercepts. Well, actually, I stand by what I said, because I'm going to introduce a new term to you guys that can be used for the same thing in a second. Uh-oh. What do I do when I see x to the third? I pull up ChatGPT, and I say, ChatGPT, please save me. And then ChatGPT saves me, but then it doesn't show up on the test day. All right. Is this something I can factor? So this first set, I'm going to make sure all the problems are relatively easily factorable. So is there something I can pull out of all these? An x, right? So I'm going to pull an x out, right? Once I pull that x out, it looks more familiar, right? Is this something that's factorable? Yeah, I think. I'm going to do my thing. 1 times 8. 1 plus 8 is not 6. 2 and 4 add up to 6. X plus 2, x plus 4. Now that it's factored, is this something I can find the zeros of, find the x-intercepts? Oh, yeah. The x in front gives me the 0, 0, right? This one would give me -2, 0. This would be -4, 0. I'm doing that pretty quick. Any questions how I'm getting these points from the graph? Getting the x, saying what do I plug in to get 0, comma 0, because y was 0. Is that almost enough, just side note, to graph this function? This is a side note. This is bonus. If this is a positive odd function, I know I start down here, and then I'm going to go do something like that, right? To draw a general graph of this, I know that there's a point there. Oh, Jiminy Crickets. Excuse my language. I have a point at 0, 0, right? -2, 0, and -4, 0. That's what that tells me. I could graph this now, right? I could graph this without using technology if I know the zeros and I know the end behavior. And that's why we study those two things. Okay? If I know zeros and end behavior, I know what it looks like. This one you're going to do the same exact way. You'd pull an x out and then factor it. Okay? Pull an x out and then factor it. If you'd like to see that one, you can watch it. I do want to spend some time, okay, we're good, on this one. Because this one you might have done grouping sometime in your life, but you use it so rarely that it's one of those things that you do it and you forget how to do it. So if you see a function like this, I can't pull an x out, can I? So if you can't pull an x out, I would say try grouping. So what I would do is I'd group it into two sections. Okay. In that first two, is there something I can pull out of both of these they have in common? Look at my smallest one, an x squared, right? So I'm going to pull out an x squared and make this into x plus 7. Okay. This one's probably this is the toughest one of the day. This one's all, but honestly, if you get good at it, it's actually not a lot of work. What can I pull off both these to make it look like x plus 7? They're both negative, so I can pull out a -3. Okay. Uh-oh, are these the same? They are. So I can actually rewrite this as x squared minus 3 times x plus 7. And that's actually fully factored. That's done. Because it's distributed. This is distributed property. Yeah. So I can pull them both out in front again. If you FOIL that out, it equals the same thing as what it does up above. I'll do another one down here. That's a grouping as well. So now, can I find my zeros? I can. So this one's a little bit different. So I have to think about this. What you're doing each time after you factor is you're technically setting each part equal to 0. That's how I'm getting my number so quick, right? Like I can look at that and say -7 plus 7 is 0, right? Because I'm solving that equation, all right? X equals -7. Subtract 7 from both sides. That's what I was doing earlier. I should have probably just showed you guys that. I need to know when will that equal 0? When does that piece equal 0? What do I do to both sides? Add 3, right? And then I square root it. Now when I square root this, I get x equals plus or minus square root of 3, correct? Because I need two answers for it. Whenever I square root to solve, you get two answers. Okay? Yeah. So how many zeros do I actually have? A lot. I have -7, 0 from this one. And then what? I have -√3, 0. this, positive root 3, 0 from that. Okay? There's one of these ones on the homework set. Let's do, did I do that bottom one? I never found my notes. Let's do the bottom one. If we can do the bottom one, we can do anything. We're going to see this unit. Oh, mamma mia, that's spicy meatball. I gotta stop doing that. Yeah, it works. All right, is there something I can pull out of all these right away? Look at my last one. What can I pull out of it? An x squared, right? So I would do x squared times 2x3 minus 9x squared plus 10x minus 45. Right? Okay. So now I pull out the x squared. I'm going to ignore it for a while. Is that okay? I know in my final answer there's going to be an x squared. I'm going to try to group them because that's the only tool I'm teaching you guys right now. I'm going to show you guys another tool later. Is there something I can pull out of both these? Not the 2 and the 9, right? But what about that x squared? Yep. So I'm going to pull out an x squared. That becomes 2x minus 9, right? I just pulled out an x squared. That is an x squared. That is 3x's. What's up? You 100% could. I just always like to get rid of anything I can right at the beginning because I know then 0 is just 0. Could I have grouped them right away? Yeah, you could have, and pull an x to the 4th. But then you're going to have another factoring piece after. It's always easier to take out, like if they're all divisible by 2, do that right away. It will make, there's one less step. But you could have grouped them right away. That's a astute observation, young man. All right. What do both these have in common? Only one has an x, right? What do they have in common, though? What can I pull out? A 5, right? Because what's 10 divided by 5? 2. Negative 45, negative 9. So when I did that, it worked, didn't it? I got it. Now we're good. We're good. We're actually really good. So now what can I do with this beast? I'm going to write it over here. What can I do with these two? Combine them. And then the 2x minus 9. I would highly suggest, if you're someone who needs a lot of practice, the OpenStax book does have extra problems with these because grouping looks difficult, but I assure you the more you do it, it's actually quicker and quadratic, right? How many steps did I do to factor this? There's 2 steps, right? This was a 2-step. It just looks really difficult. But if you want more practice, I can get you more practice on this. So, what's my 0 for this number out in front? 0, 0, right? What do I plug into x to get 0? 0. All right. I'm going to set this thing equal to 0. So I get x squared equals negative 5. Now, when I square root this, can I get an answer from square rooting a negative? Yes, but will it be on the graph? So what do I do with a I answer, a complex number for the graph? You ignore it. That is not going to be a 0 on the graph. You cannot have i's on a graph, so this is going to give me no zeros, no x-intercepts. This one will, though. When is 2x minus 9 equals 0? 2x equals 9. X equals 9 halves. Or 4.5. I just solved that equal to 0. So I get 4.50. So how many x-intercepts did I have on that silly graph? 2. It only hits twice. It only hits twice because we ignore complex numbers for x-intercepts. All right? Perfect. All right. Last thing we're going to talk about is called the intermediate value theory. Intermediate value theorem is this. It states that if a function is continuous, it hits every point in between those 2 points. That sounds goofy. What it's basically saying is this. If I have a graph that's continuous between this point and this point, if this, let's say this highest value is 5, my y value is 5. So this could be like the 0.35. And this could be the point -1, 0. What this is saying is, will there be a value between here of y that's 4? Yeah. Will there be a y value that's 2? Yeah. Because no matter what, you have to hit every value between 0 and 5, right? It's continuous. So this is a lot just to say we hit every value. Will there be an x value that's 0? Yeah. We hit every point between 0 and 5 for y. Okay? So we have a continuous function. F of 2 is 14. F of 5 is 39. So think about that graph I just did. We have the point 214, and then it's going to go up to the point 539, right? So do I know for a fact that there is somewhere on this function that y equals 22? Will there be somewhere in here that I hit 22 with my y? Yeah, that's all it's saying. How do I know? Because 22 is in between 14 and 39. I don't know. I wish they would word this better. Now, is there a number between 0 and 2 that gives you 22? Do I know what f of 0 is? So no, I can't. Can I make a conclusion about something if I don't know about the upper and lower end? No. Let's do this one. So think about it like this. We have the point 7, -2. Squiggle, squiggle, squiggle. 8, 11. Is there a number between 7 and 8 that will be a 0? Is 0 between -2 and 11? Yeah. So what we know is a 0 exists between those 2 points. Will there be a number, or is there a way that we can get -5? No, because -5 is less than -2. Could we have a point that reaches it? Yes, but we cannot guarantee it. This is actually some theoretical stuff. All right, here's what you're going to do with it. Will we find an x-intercept on that graph between 0 and 2? That one is not factorable. That's non-factorable. We don't have any tools to do it. Here's how I would do it. Remember with the arc, the average rate change, we had to plug it in to find our y values? So we need to plug these in to find our y values. I need 2 points. So I'm going to do f of 0 equals 0 minus 0 plus 0 minus 1, right? Which is -1. So I have the point 0, -1, because before I gave you the 2 points, right? And that made it easier. You just have to look at them. Here we have to find our 2 points. plug it in, find our y. So that's one of our points. Then we would do f of 2. I'm pretty sure this is a typo and that should be a squared. But I don't think it'll matter. I'm going to plug it in as it says. 2 to the third minus 2 times 2 plus 2 minus 1, right? So what's 8 minus 4 plus 2 plus 1? I'm just plugging in 2 to my function, right? So that's 7, right? So I have the point 2, 7. So I got my 2 points. So the question is this. Between 0, 1, negative 1, and 2, 7, is there a shot that y would be 0 at some point? I mean, does it have to have a point where y is 0? Yeah, because what's my lowest y value? Negative 1. Highest one is 7. So can we find x-intercept? Yes. Because we have to have y equals 0 at some point. You have to. Right? Because it's continuous. You're going from 0, negative 1 up to 2, 7. At some point, y will equal 0. All right? That was a lot. That was a good one.